Hello class, and welcome to lesson 5.8b. Today we'll be taking a look at using the quadratic formula and applying it to a couple real life situations in the real world. Okay, but before we do that, let's just go over our three different types of solving. So we're going to solve by factoring in question 1, we're going to solve by square root method or completing the square method in question 2, and solve using quadratic formula with question 3. Those are the three methods we learned to solve. Okay, I'm going to ask you to pause the video and solve, and I'll put the solutions up on the next page and go over it. So pause your video. Okay, welcome back folks. Hopefully you've done your warm-ups. Here are our solutions and I'll explain them. Method 1, ladies and gentlemen, you got to take your 100, bring it over, becomes negative 144. That's a difference of squares. You find your factors, use your zero product property, and you get x equals negative 12 or x equals positive 12, or you can write down x equals plus or minus 12. That's one thing you can write down. Okay, second example, ladies and gentlemen, is a simple trinomial. So you got your product of 16, your sum of negative 8. Two factors are negative 4 and negative 4. That is good because they're the same, folks. So you can square them, and you can turn out using the square root method. Okay? Or you can just realize there's going to be one solution because it's going to be x equals 4. All right? Okay, taking a look at example C, it's a common factoring example, folks. So you common factor out an x. And if you want to, you can put it into standard form first, but you're still going to get the same answer. After you common factor out an x, you know x equals 0, or you take the bracket, simplify it for x, x equals 6 over 5. That's factoring method. Okay? Second is by using the square root method. So if you have an example like A, where it's the variable binomial squared, you do the opposite, which is square rooting, because squaring and square rooting cancel each other out. Just remember, when you take the square root of any value, it's going to be the positive or negative value. All right? So once you take the positive negative value, you take your negative 5 over, becomes positive 5, break it into its two cases, and solve. Okay? Second example here, ladies and gentlemen, notice that we have a bx term, okay, or we have two terms that have c in it, so we've got to complete the square. So that's where we complete the square here in method B. Okay, so first thing you got to do is take your 12, bring it over, becomes negative. Then you're going to use your strategy, b divided by 2 equals negative 4, which equals 4 divided by 2, which equals 2. Then you square it, so 2 squared equals 4. So that's the number you're going to add and add to both sides. Okay, collect like terms, and you notice this is a perfect square, so this becomes c plus 2, and you have negative 8 on the right side. Square root both sides, and what you realize, folks, is that you have a negative under the square root, so that means there are no roots. Last example for warm-ups says solve using the quadratic formula. For A, you had to take the negative 28 over and bring it to positive. Then you set it in the formula. You simplify the formula, split into its two parts, and you should get x equals negative 2.10 and x equals 4.44. Awesome. Next example, folks, we have values on both sides. You've got to bring them all to the left. Okay, after you get them on the left-hand side, folks, you're going to realize that A equals 4, B equals 9, and this is a tricky one. Be careful here. C, there's no value for C, so C equals 0. You've got to plug that in your calculator. It's helpful when you plug it in, because when you put it into your formula, ladies and gentlemen, anything times 0 is 0. That's why that crosses out. So you're going to have square root of 81, which is just 9. So you got 9 plus or minus 9 divided by 8. Okay, break it into its two cases, folks, and you've got G equals 2.25 and G equals 0. So those are your two cases. Okay, I'm going to pause the video and I'll continue in a little bit. Hey class, welcome back. Sorry about that. So we just did the warm-ups, and I have the answers posted on the website if you need some help with that as well. So today we're getting into the applications. So what we're going to do is we're going to take the quadratic relation and we're going to solve it with real life or real-world applications. So our hint, folks, is we're going to be subbing into a variable given. So sometimes we're going to let, h equals 0, or t equals 0, or profit equals 0. And then we're going to solve by factoring or by using the quad formula. All right, so let's take a look, folks, here at this first example. Okay? First example is a diver jumps off a 3-meter springboard. Her height in meters above the water is in t time, which is seconds, after she leaves the board, is given by this relationship. Now, folks, hopefully you remember that this is in standard form, and what we know, folks, is that the standard form gives us the initial y-intercept, which in this case is the initial height. Okay? So what does that tell us, folks? That tells us that initially she started at 3 meters. And of course, it says it right here. But I'm just letting you know that that helps you to develop a graph. So the first thing I want to do, folks, is I want to draw a graph because that's your y-intercept. Okay? So in this case, instead of having x and y, we've got t and h. Okay? And what do we know about our height? We're starting at 3. Okay? And, oh, sorry, I'm going to make that a little bigger, so just let me erase that, because you don't get too much bigger than that. So I'm going to just put it up a little higher. Okay, so we're going to start at 3 meters. We're going to jump up and come back down. Technically, ladies and gentlemen, there's a second part of the parabola where she's getting up onto the, stepping up onto the springboard, but we're not going to worry about the negative part of the parabola. Okay. So please draw that graph. So what does that tell us? That over time she gets to a maximum height, which is here, and then she falls down and gets to the water. All right, so let's answer some questions here. A, when did she reach the water? So what we're looking for A part, ladies and gentlemen, is where her height is 0. So that's going to be at the x-intercept. To let the x-intercept, you got to let the height equal 0. So we're going to sub or let h equals 0. So we're going to rewrite this equation, and wherever we see an h, we're going to put a 0. So it's going to be 0 equals negative 4.9 t squared plus 8.8 t plus 3. Now, ladies and gentlemen, in order to solve this, we could either factor or use the quadratic formula. As soon as you see decimals, ladies and gentlemen, we know it's not going to be possible to factor, so we're going to use our quad formula. Just if you forget, A equals negative 4.9, B equals 8.8, and C equals 3. So let's sub it in. And what's our variable this time? Instead of x, folks, we've got t. So t equals negative b, which is negative 8.8, plus or minus the square root of 8.8 squared minus 4 times a times c. Okay, and that's all divided by 2 times a. All right. Okay, we're dealing with decimals, so your calculator do the same thing. You just got to plug it in very carefully. Okay, so let's simplify inside the square root. So let's use that to get one value. Okay, plug in your calculator. You should get altogether 136.24. Okay. And taking a look at the denominator, ladies and gentlemen, you should get negative 9.8. If you tend, folks, to take physics in grade 11, 12, or in university, they're going to talk about a factor called the acceleration due to gravity, and it's 9.8 meters per second. So that's where that's coming from, ladies and gentlemen. Okay, so I want you to recognize that because that will come up in physics when you take a look at that. All right, so now that we've got it, ladies and gentlemen, simplified, we're now going to break it into its two cases. So t is either going to equal negative 8.8 plus the square root. That's one case, or one answer will be there. Okay, or we're going to break it into the second case, where it's negative 8.8 subtract the square root of 136.24. all divided by negative 9.8. Quick reminder, ladies and gentlemen, when you're doing this, typing it in your calculator, you got to press equals after you do your numerator, then divided by the denominator, which is negative 9.8. So plug it in your calculator, ladies and gentlemen, you should get t equals negative 0.29. That's one answer. Okay. And the second answer, folks, if you plug it into your calculator, should be 2.09. So we've got two answers, folks, and let's go back to our graph and see which one makes sense. So if I go back to my graph, I've got negative 0.29. That's the negative one. We're not worried about that, so draw a slash through it so you know that that one doesn't matter. And your second one's going to be positive. That's the one we actually want to do and include in our therefore statement. So therefore, she reached the water at 2.09 seconds. All right. Awesome. There's the first question done. Let's take a look at the second question. The second question says, when was she 2 meters above the ground? Okay, so we want to talk about the height being 2 meters. Okay, so we're going to see about h equaling 2. Okay, so if I quickly take a look and resketch my graph, I know I'm starting at 3, I'm jumping up, and I'm coming down. Okay, technically I've got the other part of the parabola there. And if I sub in h equals 2, ladies and gentlemen, 2 is below 3. So on my 2, so we're going to have one data point that's positive and one that's negative, kind of where I drew the 2, right? So let's put it there, okay? And we're not worried about, we're going to ignore, when we get our answer, we're going to ignore the negative one and deal with the positive one. Okay, so let's rewrite our equation. Wherever we see an h, we're going to put a 2. So it's going to be 2 equals negative 4.9 t squared plus 8.8 t plus 3. Now, in order to use quadratic formula, folks, you have to have one side equal to 0. So let's just take this 2 and move it over. And collect like terms right away, just to save yourself a line. If you need 2 lines, do it by all means. The 2 comes over, it becomes negative, so 3 minus 2 is plus 1. Now that you know what your A, B, and C are, you can plug it into your formula. So it's going to be T equals negative 8.8 plus or minus the square root of 8.8 squared minus 4 times A times C, which is 1, sorry, let me back that up. Okay, and it's all divided by 2 times negative 4.9. All right, use your calculator. Make sure you keep it with you, guys. Okay, simplify the square root. Okay, plug it in, and you should get 97.04. And the denominator, again, is 9.8. All right, now that we got that, folks, we can break it into its 2 cases. So t equals negative 8.8 plus root 97.04, all divided by, remember to press equals first, and then divide by negative 9.8. Plugged in your calculator, folks, and you'll get negative 0.11. And if you think about it, folks, can time ever be negative when you're taking a look at a problem? Not really, unless you're going back in time, but that's not what the question asked. So your second root, ladies and gentlemen, t equals negative 8.8 minus root 97.04. Press equals, and then divide it by negative 9.8. And your time here equals 1.90. What does that mean? Therefore, she reaches 2 meters at 1.90 seconds. Okay, so just double check with our graph, folks, that we drew initially. That's this point right here. Okay, we have to double check to make sure it makes sense. We know she hit the ground at 2.09 seconds, so it had to be less time than that. So let's just see, is it reasonable? Yeah, it is. Okay. All right, last question, C. Okay. Question C says, when was she 7 meters above the water? Now, 7 meters is pretty high. So that means a height. So height equals 7 meters. Okay, so we take a look at the graph that we drew initially. We started at 3, we went up. Okay, we know we're at 3 to start with, but we're not sure, does 7 fit here or is 7 above? Okay, we'll have to figure that out. Okay, so let's sub it in and find out. So again, wherever you see an H, you're just going to put in 7. You don't need to actually put the meters in. Okay, so you're going to go 7 equals negative 4.9 t squared plus 8.8 t plus 3. Remember, before we use the quadratic formula, folks, you need to get 0 on one side. So you're going to collect your constant terms on the right. Okay, and you should have minus 4 here, ladies and gentlemen. Okay, now we're going to plug it into the quad formula. So t equals negative 8.8 plus or minus the square root of 8.8. Sorry, make that down there. Squared. I got to fix that. Sorry, looks too bad. I want to try to be neat. I'm sorry. There we go. Let me fix it. So 8.8 squared minus 4 times a times c all divided by 2 times a. Okay. Okay, simplify your square root in your simplify your square root with your calculator, and you're going to get a value of negative 0.96 divided by negative 9.8. Hopefully you recognize, uh-oh, got a problem here. If not, you would get to it when you were trying to plug in your calculator. But whenever you see a negative in the square root, there's going to be no solution because there's a negative under the square root. Okay? So because of that, does she actually reach 7 meters? No. So therefore, she never reaches 7 meters in height. That's pretty high on a springboard. So just let's examine our graph, guys. That's this case here. Okay? Because there's no solution, there was no interception or no intersection points, right? Okay. All right, there's example 1. Now let's take a look at a second example. This is a business model, okay? So a business, here's a company that manufactures and sells t-shirts. The profit P in dollars is projected to be P equals this equation where X is the number of t-shirts, okay? Okay, so where X is the number of t-shirts sold in thousands. We've got to be careful. So whenever we solve for X, we've got to add thousands to it, okay? All right. So question number 1 says, when will a company break even? But before we do the first question, let's try to visualize a graph, okay? So instead of, we have X, but what does X represent? Number of t-shirts. So we got t-shirts for our X, okay? And instead of Y, we really have a P, what that means stands for the profit. Okay, if you're ever going into business, this is important to know. Okay, and remember, ladies and gentlemen, the quadratic formula comes in 3 forms. This form is standard, and the standard one gives you the y-intercept. So y-intercept equals negative 6,720. So for my graph, ladies and gentlemen, I got to extend it into the negatives, which is probably new for us. We haven't seen that too much. So what's going to happen is down here we're going to be at negative 6,720. And hopefully you realize with the quadratic, folks, it's negative 20, so it's going to shoot up, come to a maximum profit, and then shoot back down. Okay? And companies need to realize when they're at their maximum profit, they either need to develop a new product to keep them on top, or to expand their line, or to create something new. Otherwise, their model's going to go down. Okay? So the negative part makes sense, folks, because when you're starting up a company, you either have to get materials, you have to hire people, you might have to get a factory going. So you're going to be in the hole to start with until you start selling them, right? So you got to train people, you've got to do get all the licensing and get all the insurance and stuff. But once you've got that done, then you can start doing your business. All right. So the company, it says for A, It says, when will the company break even? So break even is when what? So if you're asked what break even means, that means they're not making any profit, but they're not in the hole either. So profit equals 0. So we're actually looking on the graph, folks. They're going to start in the hole, then they're going to get a profit, come up to their maximum, and then eventually come back down and have a break-even point on the downturn side of things. Okay? So make sure you know break-even point means profit equals 0. It's a good thing to know in life. Okay? Especially if you're into business. Okay? So what we're going to do is we're going to sub in a p equals 0. That's great, because then as soon as we've got one side equal to 0, we can solve. So we've got 20x squared plus 1,000 x minus 6,720. Looking at these numbers, folks, we got a lot of big numbers. So let's look to divide through every term, and we're going to divide every term by 20. So divide by 20. So you get 0 equals negative 2. I'm sorry, negative x squared. My fault. Let me erase that. Hurt. So negative x squared plus 50x. And then when you take that and you divide through, it's going to be negative 336. Okay? Plug it in the quadratic formula. We have x this time as our variable. So it's going to be negative 50 plus or minus the square root of 50 squared minus 4 times a times c, all divided by 2 times a. Okay. Simplify by doing some work in your calculator, folks. Okay. So when you simplify that, you should get the square root of 1156, all divided by negative 2. Break it into its parts. So you're going to have x equals negative 50 plus root 1156 divided by negative 2. Or you're going to get x equals negative 50 minus root 1156, all divided by negative 2. Plug it in your calculator, ladies and gentlemen. If you need to pause the video in between me doing these to actually practice your calculator, please do so, okay? So plug in your calculator. First answer is 8. And the second answer is 42. We got to remember something here, folks. We just answered x. Go back to the question at the top. Remember it said x is sold in thousands. So you got to remember that. So we're going to double check here with our graph, folks. They're going to start in the hole. They're going to come, and as soon as they sell 8,000 t-shirts, they're going to start making a profit. So 8,001 t-shirt, they'll make a profit, and they'll go to maximum profit, come back down, and as soon as they reach 42,000 shirts, they're no longer making a profit. That's a lot of shirts to make, okay? So the time in between making 8,000 and 42,000, that's going to take a lot of time to sell that. So they're making a lot of profit as they go. All right, so then we need to do a therefore statement. So therefore, break-even point, or company will break even, I'll just use break-even point, occurs when, don't forget to add thousands on, 8,000 or 42,000 shirts are sold. Okay? So there's question 1. All right, or question A. Question 2 says, how many shirts must be sold to have a profit of 5,000? So for B, guys, we're going to have profit equals 5,000. Let's take a look at our graph. We know we started, let's go, move it up here. We started way down here at negative 6,720. We go up and come back down. Okay? And we're hoping that if we sub in here, we're going to get a profit of 5,000. Okay? All right? So as soon as we sub that in, folks, we're no longer finding the zeros. We're actually finding the intercepts. Okay? But it's the same process. Okay? So as soon as you sub in a value that's where the y value is not 0, you're actually finding the zero. You're finding the points of intersection. So sub into the equation 5,000 equals the rest of the equation, negative 20x squared plus 1000x minus 6720. We need to get 0 on one side, so we're going to collect like terms on the right. So when you collect your constants, ladies and gentlemen, the 5,000 comes over, becomes negative, so you're going to have a negative 11,720. Okay. Again, folks, we're dealing with big numbers. That's the biggest number we can divide through. We're going to divide by 20 here. So it's going to be 0 equals negative x squared plus 50x minus 586. Okay. Now that we've got a simplified quadratic, let's plug it into the formula. So x equals negative 50 plus or minus 50 squared minus 4 times a times c. And we divide it all by 2 times a. Okay. Plug her into the calculator, folks. So negative 50 plus or minus the square root of, plugging it in, hopefully you guys got 156. Okay, and if you're not practicing this, folks, you should be doing it to make sure you getting the same answers. Okay. All right. Once we've got that, ladies and gentlemen, we split into its two cases. Just because I'm saving room, I'm going to go up here. So we're going to have x equals negative 50 plus root 156, all divided by negative 2. Okay. Plug it in your calculator, ladies and gentlemen, and you're going to get approximately 18.76. Okay, get your second answer, which is negative 50 minus root 156, all divided by negative 2. Okay, and that gives you approximately 31.24. Don't forget, again, folks, this is an x answer, so you got to times it by 1,000. So, therefore, 18,760 or 31,240 shirts will make a profit of 5,000. All right. So taking a look, folks, let's just make sure that makes sense with our answer. So this is going to be right here. The first one is going to be 18,760. It's going to come up to a maximum. And then it's going to be 31,240 for the second one. All right. Last question. C. C says, will the company make a profit of 6,000? If so, when? So we're going to let the profit equal 6,000. Okay. So taking a look at this, we have our initial quadratic, folks. It comes from the bottom, comes up and comes down. Okay, we know that's at 6,720 in the negative. Okay, we're not sure when it says 6,000. 6,000 could be here, or we could put a line in and it doesn't intersect. But we'll find out by doing the mathematics. So replace P with 6,000, sub it into the equation. Okay, now we need to, in order to use quadratic formula, we got to get one side equal to 0, so collect your constants. Hey, Dietz, you want to do this math problem for me? No? Okay. All right, so we collect like terms. So when you collect your constants, folks, you're going to have negative 12,720. Again, you're dealing with big numbers, so let's divide everything by 20. Okay. So we get a simplified quadratic of negative x squared plus 50x minus 636. Again, practice plugging in your calculator. Okay. Now that we've got it simplified, let's sub it into the quadratic formula. So x equals negative 50 plus or minus 50 squared minus 4 times a, which is negative 1, times c, which is negative 636, all divided by 2 times a, which is negative 1, Use your calculator to do the work, ladies and gentlemen. In your square root, what do you notice? In your square root, you're going to end up with negative 44. Hopefully that's a red flag. But if you decided to break it into its split it up into its roots and solve, you'll have an error in your calculator because you cannot have a negative. So this would tell you no solutions. Okay? Because you can't have a negative under the square root. Okay? So to answer the question, will you have a profit at 6,000? No. So therefore, the company will not have a profit at a profit of 6,000. Okay? Okay, so what does that mean, folks? If I go up to my graph quickly, that means that it in fact was this line. Okay, so this line didn't exist, and we don't know that yet. Okay, and again, if you're wondering about what would the maximum number of shirts be or maximum profit, save that for Unit 6, folks. That's coming up. Okay, so here's our homework, folks. Page 271, number 6, 9, 12, and 13. Have a great day, folks, and see me if you need any help. Get ready because our unit test is coming up soon, so please be practicing.